Wednesday, and this is chapter 12. We will start in chapter 12 today. We're going to talk about thermal energy. So let's go ahead and get started. So thermal energy. Thermal energy is where you have like hot objects or cold objects. Here you have a thermometer. That's what those two are, even though this really doesn't look like a thermometer. But anyway, so depending on the temperature is increasing or decreasing based on the particles that are inside that are bouncing off. So it says as particles collide, they transfer energy, and the number of molecules, the more collisions are going to happen, the more heat's going to happen. Okay, there is a random distribution before thermal equilibrium. So here we have two things, one thing that's hot, one thing's cold. As you can tell, the kinetic energy here is moving faster and is hotter because of the length of the arrows. This one here is a colder object, so as you can tell, they're smaller arrows, meaning that it's colder. And it's just telling you that the kinetic energy of A is greater than B. Now, when you put them together, eventually they will become at a state of equilibrium. And what that means is they're going to be the same temperature. You have hot, you have cold, and then now you have something that's completely distributed throughout the same temperature. So thermal conduction is transfer of thermal energy that occurs when particles collide. So that's thermal conduction. Thermal equilibrium states that which the energy is transferred between two objects are equal and the objects of same temperature. So here they're telling you there are three temperature scales, which you can remember back from chemistry class. You have Kelvin, Celsius, and Fahrenheit, and it's showing you the difference between those. Okay, heat is a transfer of thermal energy which occurs spontaneously from a hotter object to a cooler. And then it goes into conduction, convection, and radiation. Now remember, conduction is where you actually touch it. Convection is the motion that is inside of a container, okay, that is distributing in a liquid or a gas. And radiation is radiating like the sun does, okay? We are going to talk about what specific heat is. Specific heat is just the unit that actually raises the temperature 1 degree. Okay? So it says here the material of an amount of energy that must be added to a unit of mass of material to raise its temperature 1 temperature unit. SI unit specific heat is C, which is measured in joules, kilograms times Kelvin. Okay? So in here they have a problem, and in our textbook, the practice problem, says that a calometer contains 0.50 kilograms of water. Okay, so and it has a water temperature of 15 degrees Celsius. 10 kilograms block of a known substance at 62 degrees Celsius and is placed in the water, and the final temperature of the system is 16 degrees Celsius. So we start off first with our temperature, which our mass 1 is only supposed to be 0.10 kilograms. Okay, our temperature 1 is 62 degrees. And our temperature 2 is 16. So what we're going to do here is we just do the equation that it's asking for. And we're just going to do the math where we have these numbers here and then we just multiply and divide. So let's look at question number 1. Question number 1 tells us that there is a 1.00 times 10 aluminum block with a 100 degrees Celsius, and is placed in a 1.0 times 10 to the second thing of water, and it's asking us what is the specific heat. So for that one, we're going to take our 23 kilograms, we're going to times that by 385 joules, and then we're going to get 5.3 times 10 to the 4th joule. Next one, I'm doing the wrong one. Let me go back to the right question. Sorry. So it says, when you turn the hot water in the water dish, the water pipe heats up. How much thermal energy is absorbed in a copper pipe with a mass of 2.3 kilograms? Okay, sorry. So our mass is 2.3 kilograms, and our temperature is 385 joules. So that's 5.3 times 10 to the fourth. Question number 2 says, Electric Power Company sells electric energy at kilowatt per hour, where 1 kilowatt hour is 3.6 times 10 to the 6th joule. Suppose it costs 0.15 kilograms to run the electric heater. How much would it cost the 75 kilogram water from 15 to 43 to fill the bathtub? So what we're going to do here is we're going to take our 75 degrees kilogram, because that's how much it's going to be, and times it by 4,180 joule, and we're going to get 8.8. Then what we're going to do is we're going to take that number there, divide it by what the number was for 1 kilowatt hour, and that gives us 2.4 kilowatts per hour. And then we're going to times that by 15 to get 0.36. And then that's all I'm doing is just those two. And then the next thing it's talking about, it is actually giving you specific heat and what specific heat is. Specific heat is Ca equals a negative Mb Cb Tb divided by Ma and change in Ta. So what they have here is they have a calometer. A calometer is a device that has a double container insulated with a thermometer and a stirrer, and you put your material in, and we'll use that to figure out how many calometers there is. So let's look at our sample question. Our sample question here says that it's 10 kilograms, 62 degrees Celsius, 0.50 kilograms, 4,180 joules per kilogram, 15 degrees Celsius, 16 degrees Celsius, and we're looking for Ca. So I'm going to read the problem again because the last problem I read was this one. So it says a calometer contains 0.50 kilograms of water at 15 degrees Celsius. 10 kilogram block of an unknown substance at 62 degrees is placed in the water. What is the final temperature? So what we're going to do is we're going to take 0.50 and we're going to multiply that by 4,180, and then we're going to times that by 16 minus 15, and then we're going to divide that by 10 times 16 minus 62, and that's going to give us 450 joules. So what I have done is I went in and I put it in my calculator, and so I just plugged it in just like it shows you here, okay? And I got 4.54 times 10 to the second. If you change your mode and you move it to normal, you should get the same answer I got there. So that is our answer. So then the next one that we're going to do is we're going to do question number 4. So question number 4 says that there is a 1.00 times 10 to the 2 gram of aluminum block at 100 degrees Celsius is placed at a 1.0 times 10 to the 2 grams of water at 10 degrees Celsius. The final temperature of the mixture is 26 degrees Celsius. What is specific heat? So for that one, what we're going to do is we're going to do alpha y, enter again, open bracket, 0.100, close bracket, open bracket, 4,180, close bracket, open bracket, 26 minus 10, close bracket, go down. We're going to do open bracket, 0.100, close bracket, open bracket, 100 minus 26, close bracket, and then go over and enter. And we get 903, which was a perfect answer. Or you can go to the mode, hit enter, second answer, and then I got 9.03 times 10 to the second power. I rounded it to 4 because that 7 tells me I need to. And then question number 5 says that 3 metal fishing weights have a mass of 1.00 times 10 to the second gram, and the temperature is 100 degrees Celsius, are placed at 1.0 times 10 to the second gram of water. The final temperature of the mixture is 45. What is specific heat? So what we did there is we're taking our 0.100 times our 4,180, 45 minus 35, over 300, 0.300 kilograms, times 100 minus 45, and we should get the answer of 253 times 10 to the second. And then the last one for today, number 6, says the 2.00 times 10 to the second gram sample of water at 80 degrees Celsius is mixed at 2.00 times 10 to the second grams of water at 10 degrees Celsius in a calometer. What is the final temperature? So we're just going to take 80, add 100, divided by 2, and our final temperature is 45 degrees Celsius. Okay, so that is the lesson for today. There was one more thing on here talking about animals and thermal energy and connected it to physics. Make sure that you look that over. But besides that, that is the end of the lesson today, and then I will see you tomorrow.